Hey guys, we're going to do graphing this time, okay? Starting with your system in standard form, ax plus by equals c. We need to convert to slope-intercept. Y equals mx plus b. So let's refresh. You're solving for y, so subtract off the x term, bring down the y term, and right from here, remember, you cannot add these together. You do not get negative 3x or negative 3. These are unlike terms. Write them as you see them and put them in slope-intercept form. Negative x minus 2, mx plus b. Here is your first equation. Let's graph that. B is where we begin. Okay, that is your y-intercept. So we go to our graph, start at the origin, and go down 2. Okay, negative 2. My slope is negative 1. So remember, slope is rise over run. You can rise up or you can rise down, but you always run to the right. Don't forget that, okay? So our slope is negative 1. Down 1, right 1, down 1, right 1. When you're doing systems of equations, go all the way to the end of the graph, okay? Because you don't know where they're going to intersect. And then go all the way back. The opposite of down and right is up and left. Connect your dots. That's your first line. Okay, let's go to the second line. 2x minus 3y equals negative 9. Okay, here again we're solving for y only. So subtract off the 2x. That cancels. Where'd my green go? Okay, bring down the entire y term. That minus sign goes with the 3. This is the biggest problem right here, is forgetting that negative. Write this as you see it. Minus 2x minus 9. Okay? Now we're solving for y. Negative 3 and y are multiplying together. The opposite of multiplication is? Correct. Division. So we're going to divide this by negative 3, this by negative 3, and this by negative 3. Do not forget to divide all 3. Okay? Y equals. Now simplify your fractions. A negative divided by negative is a positive. We can't do anything with the 2/3. Negative divided by negative is a positive. 9 divided by 3 is 3. Okay? So come over here. We're going to start at a positive 3. And our slope is up 2, right 3. So we're going to go up 2, right 3, up 2, right 3. Obviously, if I keep going, I'm not going to go anywhere. My line is over here, so I'm going to go down and back. Okay? This is my point of intersection. This is the point that solves my solution. My answer to this is negative 3, positive 1. This is the ordered pair that solves both equations. Okay, remember, when you have a system, you're looking for the point of intersection. That's your answer. Okay? Remember, these notes are on eCampus, so I'm going to erase. I'm going to do the second problem. X minus y equals 2, and negative 3x plus 3y equals negative 6. Okay? When they're in standard form, Always put them in slope-intercept first. Much easier. Subtract the x term off of both sides. Bring down the minus with the y. Write this in slope-intercept form. Negative x plus 2. Now, here's very, very important information. You cannot have a negative y. You have to get rid of that negative because we are solving for y. So, in order to get rid of that negative, divide by negative 1, not negative y. Do not ever divide by the y. Divide by negative 1 here, here, and here. Your negatives cancel and you get y equals. Your negatives cancel again and you get x minus 2. Positive divided by negative is a negative. Okay? mx plus 2, or mx plus b, I begin at negative 2, and my slope is positive 1. So I go up 1, right 1, up 1, right 1, all the way till I can't go any further, and then all the way back. Okay? Second equation, do the exact same thing. Negative 3x plus 3y equals negative 6. This time, you have to add the x term. It's already being subtracted. You undo it by adding it to both sides. Bring down the y term. Again, you do not get negative 3. You do not get negative 3x. You cannot combine these. Just write it as you see it. So you get 3x minus 6. Okay, always divide by the number in front of y. Here, here, and here. Always remember to divide all three. The 3's cancel, and I get y equals. These 3's cancel. X, negative 6 divided by 3 is negative 2. And what do you notice? They're the exact same line. Okay? If I were graphing, I don't need to regraph it. It's already been graphed. So my solution is, if I have one line that is exactly the same as the other line, they overlapped. So my solution is all of them, infinitely many.